Welcome to Study Loop.
The formula for the mean of a geometric distribution is mu equals 1 over p, where p represents the probability of success. We're also going to find the standard deviation of a geometric distribution as well, and that is found using the formula sigma equals the square root of q over p squared. The p in this also represents the probability of success, and q is going to represent the probability of failure. And we have to just keep in mind that the probability of success plus the probability of failure will always equal 1. So let's read this problem and determine what the values of P and Q are. So here we're talking about the estimate of 4 out of 5 preferring showers. So if we're going to find the mean of those who prefer showers, then our probability of success is going to be 4 out of 5. So in this problem, the p-value is 4 out of 5. So that means our q value is going to be 1 out of 5, because that would be the one person that would not prefer the showers to the bath. So in order for us to determine the average of this distribution, we will substitute these values in. So you're going to have mu equals 1 over the p-value, which in this case is 4/5, which is the same thing as saying 1 divided by 4/5. And when you divide by a fraction, it's the same as multiplying by the reciprocal. So we end up with 1.25 men as the average of this distribution. Now to do the standard deviation, we're going to apply the second formula. So sigma equals the square root of our q value, which is 1/5, over our p-value squared, which is 4/5 squared. So we're going to do a little bit of cleanup before we grab that calculator. So we're going to have 1/5 over 16/25, which is the same thing as 1/5 divided by 16/25. And again, dividing by fractions, we end up multiplying by the reciprocal, so we get 25 over 16. And if we were to multiply straight across the top, we'd get 25, and across the bottom is 80. And we could reduce or simplify that fraction down into the square root of 5/16. We could then pick up our calculator, and we get a standard deviation of this distribution to be approximately 0.559. So just to recap, the mean of the distribution is 1.25 men, and the standard deviation would be 0.559.